In this project, we'll show you how to go from a simple sketch or drawing that you or your students might have made on paper to a two-dimensional, 2.5-dimensional, or even three-dimensional finished product using some principles of manufacturing called machining and tools that are available in most tech ed classrooms. Safety is, of course, going to be your top priority in any tech ed environment, and it's important that as a professional, you do your due diligence and educate yourself about the potential risks for your specific equipment, and that you take steps to mitigate those risks as much as reasonable. A few of the potential ones that our group foresaw using some of our equipment are listed here, as well as possible steps that you could take to mitigate those risks. A few ethical considerations when you're using a 3D printer, a CNC router, or even a simple vinyl cutter is that students, of course, and understandably even, would be tempted to download and use copyright images, maybe of their favorite logos or favorite sports teams or favorite designs, without really respecting the intellectual property of the copyright holder or the designer. And I think that's a good opportunity to have a conversation with your students about the practices of good digital citizenship and to teach them a little bit about copyright and fair use and what the law actually is surrounding using downloaded materials. We've included some links to commonsense.org's digital citizenship curriculum. There's some really good resources in there that can be applicable to any grade level, as well as the CCME document about teachers and copyright in the classroom. The materials we have in this presentation can be adapted up or down to be used in just about any secondary level tech ed classroom, depending on the students and the resources you have available at your school. We've included potential outcomes from the grade 8 curriculum, some teaching, learning, and assessment ideas, all the way up to grade 11 and 12 communications tech. Quite simply, it's a manufacturing process where material is removed to reveal a product of the desired shape and dimensions. It's sometimes called the subtractive process for that reason. It's been around for as long as we've had tools to shape materials, and regardless of whether you're using steel or plastic or wood, the same basic tools are used with different degrees of precision and complexity and automation. A lathe, a drill, routers, saws and planers and grinders, they're all doing the same job of removing material. The benefit of using CNC for that is that you can have a repeatable experience and it's much more precise. Whether you're using a vinyl cutter or a CNC router or a 3D printer, you need to have a way to get your design from your computer to the machine. And most devices make use of images to do that. Some common image formats you might encounter are raster images and vector images. Raster images are the ones you want to avoid. They use pixels to draw the image on the screen by coloring in a grid of red, green, and blue. And from a distance, the human eye can blend those pixels together to create an image. The problem with raster images is, even though they include a great amount of detail and a huge palette of colors, is that they do not scale up and down very well, and they're incredibly difficult for a machine to trace a pattern or a path from. They're more appropriate for digital images such as JPEGs or GIFs or bitmaps. Vector images, on the other hand, don't use pixels. Instead, it's a series of commands and instructions telling the computer to produce pathways, shapes, polygons, and points on the screen at specified coordinates relative to each other, and that is what produces the image. They're easily scaled up and down because the points and positions of the pathways and polygons are all the same relative to each other. So the image quality doesn't suffer when you reduce or enlarge. For that reason, they're very suitable for drawing logos, for drawing images that you do need to resize for any purpose. And They're also quite suitable because they are already a series of coordinates and pathways. They're quite suitable for use with CNC because the cutter knows exactly where to go after making each subsequent cut. So when you're planning out what design you want to cut on your CNC machine, it is important that you think about vector images. You can download many online, respecting intellectual property, of course. What you want to look for is an SVG file extension. That stands for Scalable Vector Graphic. Or you can make your own. Adobe Illustrator is an expensive yet incredibly powerful tool for that. SketchUp is, there's free and paid versions. A little more useful creating 3D vector images than 2D. Inkscape is the standard free version that a lot of people use. It's available for 3 different operating systems. I've included a link on the slides to how you can get your own free download. So now I'll show you how to create a vector image using Inkscape. The purpose of this part of the video is to show you how you can go from an idea that you've scratched down on paper with a pencil to a vector image and ultimately to a final piece that you have machined out using a CNC router. I quickly scratched down this outline of a mushroom, snap a digital photo of it, and upload that picture to your device. Next, choose which vector image editor you wish to use. I'm using Inkscape, mostly because it's free and it's relatively easy to use after you get over the learning curve. Your first step is to import the digital photo that you took into Inkscape. Next, you want to add a new layer, because all of your work is going to be done on a different layer within Inkscape. You're just using your hand-drawn image to trace. So I'm going to click on Layers, Add Layer. I'm going to call this layer Image for CNC. I'm going to go back to the layer that I originally had, and I'm going to rename it as well, just so I do not get confused. I'm going to change its opacity so that it just barely shines through. I'm just using it as a tracing path. And then I'm going to lock that hand-drawn image layer so that I don't accidentally do any edits on it when I know I should be doing them on my top layer. So I'm going to zoom in a little bit. It helps to encourage your students to zoom in as much as possible, just so they know they're getting an accurate detail. Most of my image is simple curves and ovals. So I'm going to be using the curve tool for most of my drawing today. It takes a little bit of getting used to. Pardon the pun, there is a learning curve. It would benefit your students to get the hang of how these curves work before they start getting frustrated with their own project. You can do this in just a few simple arcs. I'm going to take my time and do multiple arcs. I click on the start point of my first arc. I'm going to click on the end point. And I'm going to hold the left mouse button down and drag this blue line until the red curve follows my hand-drawn path. And it turns green. However, I can just click over on this menu and it'll show my actual finished curve. And I'm fairly satisfied. That's following my hand-drawn line fairly closely. So I'm going to continue by drawing new curves. So I'm going to click the curve tool again. I'm going to hover over the end of my last curve until that node turns red, because I want it to connect directly to my last curve. Click. Click on my endpoint and hold the left button down again, and just maneuver the red line until it follows my hand-drawn curve. And I'll repeat the process until I'm done the outline of my mushroom. But that's a pretty reasonable facsimile of my hand-drawn image. But I have noticed that my lines that I drew in the software are a lot skinnier than the ones I drew with my pencil. So I can change that by Control A to select all of my lines. And then there is a shortcut command, Control Shift, then the letter F, to bring up the fill and stroke menu. You can access that through the top menu as well. It's just easier to remember a few of the keyboard shortcuts. And if I go to width, I want to increase the width until it's about the same size as the pencil lines that I drew. I don't need my original hand drawing anymore. So I can go to my layer menu again. And if I turn off my hand-drawn image layer by clicking the eyeball, I can see that my vector image is looking pretty good. I'll turn that back on. I'm going to unlock my hand-drawn image layer now, and I'm going to delete it. And I'm left with my vector image, which I can now save as an SVG, a scalable vector graphic. There's multiple file formats you can save as. A plain SVG is the one that you'll often have the best bet with. So that's how you create a SVG file from a hand-drawn sketch. Next up, Adam is going to show you how to take your image file that you've created and load it into a specialized piece of software to prepare it for use on his CNC router.
This video is going to deal with iPicture software that's typically installed on your school's computer. We're going to take an image and open it up from a Grayscale library DVD. In this case, we're going to deal with a piece of font, the letter A, a decorative version. Double click and it'll import it into your program. Another way of going about it would be to drag and drop the image in as well. So we'll find the decorative A once again and just simply drag it into the software program. I'm going to go over some of the parameters you can do with your units. Can be changed to metric, millimeters, or in our case I'm going to use inches. This is the x-axis and the y, and then your depth, the z-axis. So right now the image is too big for my material. I'm going to scale it down to 5 inches in width, and it's going to keep the aspect ratio for us. So what iPicture actually does is it's going to take in this case, the darkest image, and if I click this button over here to invert, the darkest image is going to be the top, and the light is going to be the biggest depth. Choosing the tool here, the tool that's in the machine is a 1/32 bit, a V bit. And the feed depth per cycle here is set to 1 inch, which would be a lot, but being our project, it only goes down to just over 1/10 of an inch. That's going to make sure that the project's done in one path. So we're going to look at a preview of this piece. Again, I have it inverted, so the light areas of the A should be the deepest, showing you where your origin of your tool would be. This is the left side. I'm going to stick with the center origin. Therefore, when I set up the machine on the CNC, I know that my start point will be the center of my project, so that I can measure my border around. So here we'll look at the preview tool, and it should show you a 3-dimensional preview of your project. It's just going to take a moment to load. It doesn't look like much at first, but if you move it about and zoom in, then you can see that the lighter areas of the image are going to be machined deeper, right down to the maximum depth, and the darker areas are going to remain at the top of the project. So we'll just show you the difference if we unclick the invert dark area. And in this case, the preview should show us something that the lightest areas of the grayscale 3D image will be at the top of our project, and the dark areas will be machined out of the wood itself. And there you have the difference in their inverted value. So now we have the lightest parts of our image being the highest points, and the darkest part of the image being our maximum project depth. So this is a little bit about iPicture. Convert your file, and what it's going to do is convert this bitmap image, in this case, into a G code. So we're just going to change that and name it, and we'll put it onto a USB device, thumb drive, and then we will put that into our CNC machine.
All right, good day, all. It's Jimmy White with the low man on the machine path totem pole, or image to machine path totem pole, the vinyl cutter. Um, Super attainable for schools, not an expensive machine, really isn't. I think mine with a bunch of vinyl and weeders and a couple of little odds and ends was about $1,000, $1,200 type of thing. And I got most of it subsidized through my tech ed leader for my board. So but definitely very usable. I use it all the time for stickers for computers, for differentiating for classes, um, stickers for schedules on whiteboards that are like static schedules. And then I've tried t-shirts, doesn't go so great. I do a lot of etchings. That's kind of the idea. If I can get on there. Where are you? There we are. So you'd apply a rectangle essentially on the outside, stick on the letters as well with transfer tape, which is masking tape. There'd be a cutout oval. It gets etched with cream. Rinse it off. Boom, you have glass. So kind of cool. It's used for stickers and signs and stencils. Some companies cut out really thin magnets and put it on the side of cars. I say low man on totem pole because CNC router is doing all the work for you. You've told it's gonna either cut out the shape or cut out around the shape, and it digs away, and when it's done, it's done. And the 3D printer is building up whatever it is that you have created. The vinyl cutter only cuts in straight lines. It's 2D, so it cuts vinyl, which is plastic with a rubber backing, self-adhesive backing, rather. And then you pick off, you weed with this cool dental-looking tool, the parts that you don't want, or leave the parts that you do want. So a negative image is what you've taken off, or negative decal, and what you leave on is a positive decal. A negative positive kind of gets a little wishy-washy with students. So essentially, like, what do you want your final product to look like, and then you work backwards for what you weed off or release. You can draw things in the program. So this student, Floyd fan, so he imported hammers into this program that I have open in front of me, and then he drew the line after he manipulated the hammers into a circle. Obviously, the line drawing wasn't ideal, but on the right track. When he's done, there'll be cloudy hammers in a line, and the circle will be gone. So you can do that within this program called Cut Studio, which is extremely powerful, but not super user-friendly, similar to what we kind of went through with computers courses. So very powerful programs, but you don't have a lot of time to figure out all the things. Much easier, much more effective. Go find a vector. Why a vector instead of raster or pixelated? The vinyl cutter moves in a straight line. It lifts up and goes back down. So if it's pixelated or it's shaded in any way, it's going to jab the paper or the vinyl, and it's impossible to pick or impossible to weed off. It just doesn't work. So vector is an A to B. It doesn't lose any detail when you scale it either, which is helpful. So if I plop in my canoe paddles in Canoe, I scale it down to the size that I'm looking for. Then I extract my lines, which is neat, contour lines. So this is actually what the printer is going to cut. So vinyl cutter actually cuts the blue. And as you can see, some of these are very, very, very thin. So I would recommend the students make it bigger or get rid of them. Because when you are weeding it, something that small is going to be annoying and probably isn't going to be very successful. So for this situation, I draw a box around the whole shebang, and I draw a line at the bottom. So after my item is done, the cutter will cut right across, and then I know where the next person can start from. So if I look on where my mouse is swinging around here, this white part, I actually use my weeder to remove that part. So if I do my image, I'm going to have, if I etch it, I'm going to have clear paddles and clear canoe and a white cloudy background. Some limitations: you can only do one color, so you can only do one color of vinyl, whatever you have. You have to build things up and kind of really play with what goes where. Weeding, if you were good at operation, you will love it and you'll have no problem. If you're like me, you'll want to sit beside the person that liked operation. Actually, for a lot of my students and myself, I get to this point. Otherwise, sometimes I can't see what I'm getting at, or I can't tell if I've pushed it down. Sometimes two weeders is helpful. Super attainable machine, like I mentioned. It definitely illustrates the importance of a vector, and definitely something kids can really get into and enjoy. So
So my portion of this project was on 3D printers. I was graciously lent this 3D printer here because our school has a couple, but not as easily accessible. So this one here is the Lulzbot Mini, which is not available anymore, but the Lulzbot Mini 2 is available. Most schools have these, and they're super handy. These run about $1,100, and the really cool thing about the 3D printer is it enables students to see. I mean, really, the essence of our project is image to model, but this enables students to get a hands-on representation of what they have been designing. So just like we used this earlier on in our program, students of really any age are able to design something and create it. So they can use this for exploratories. They use this for the after school programs that we've had. I mean, we've used these in our tech ed programs to try and recreate parts, or they could build pretty much anything with them. So the process is really not that hard. There are different kinds of 3D printers, but as I show you later in this video, we're going to focus on one particular kind. We decided to use Thingiverse because it contains a whole bunch of images and they're free. So if you, as you can see in my Google Slides presentation, you go into Thingiverse, type in whatever you're looking for. I decided to look for a Bruins logo. We found that, saved it as an STL file, and then opened it up with Tinkercad. We're all familiar with this. And all they do here is edit the file to whatever dimension in any plane that they want. My recommendation, just like I said in the video, is to make a holo design and make it smaller, just because the time that it takes to print something off is can get a little out of hand. So you really need to keep this in mind, especially if you have a lot of people, a lot of students in the class who are looking to print something off. I mean, the image I did was 4.5 centimeters by 4.5 centimeters by, I think, maybe 4 millimeters thick, and it took over 20 minutes to do. The original size that we had was something like, I think it was over 2 hours. So just by shrinking that down, it took a lot less time. So it's something to keep in mind when you're doing this, but it's really good to get the students to have a hands-on approach and figure out how to use this. I'm now going to go on to the specific type of 3D printer that we would use and we'd see most often in the schools.
So FDM printers are the most popular because it's an additive process. It's not that messy, it's not that hard to use, and it uses filament, which is pretty cheap. So this prints at about 100 to 20 micron layer thickness. That's the lowest that most printers can go, which is really, really thin. So you're going to get nice and smooth prints with FDM. And like I said, FDM is an additive process. So it uses a spool of filament plastic and it extrudes that through a hot nozzle at 195 degrees Celsius or around that temperature. And it extrudes it through a cone-shaped metal piece called the hot end and extrudes that out into a really, really small, thin strand. And the printer moves around in three-dimensional X, Y, and Z planes and squishes those layers onto the bed on top of each other, as you can see here. So that's the most common type of 3D printing.